So in your project, there are several things that we want to talk about here. First, you should make sure that you are doing well as a team. If you aren't, be sure to talk to me. At this point, you should all be doing your part of the project. If you're having trouble understanding how to divide up the work, come talk to me or your TA. At this point, you should be thinking about how to put this together. The amount of code here isn't too bad, but typically you have 4 people in a group, and so there should be enough people in place to do the actual coding. Now, you'll want to set up your project in an organized fashion. Make sure that it's in GitHub. You'll also want to start to think about how we're going to divide up the code modules. This is a relatively large project, and for many of you this may be somewhat difficult, which is understanding how to create modules, and that's one of the things we're going to be looking at this week. The other thing you're going to want to do is to start to sketch out a basic domain model, and there's a separate portion of this that talks about starting to create that model. We're also going to be looking at some examples later on. Some basic problems that you may be running into with this is in reading in the command files. You should have probably somebody who's responsible for reading in a command at a time and doing the basic parsing. Now, you've probably done this in other projects in your other classes where you've just scanned in tokens, and I'm not looking for something particularly complex, but it should be robust enough that if it doesn't recognize a command that it rejects it, and that the command should have the right arguments with it. I've made it so that the commands are relatively simple in their parsing. The other problem you may run into is the fact that the two files, the two different inputs, whether it's a file or from the command keyboard, it's really exactly the same thing. Just think of standard in as being a regular file, but that each time you enter a command on the line and you read it in, you're going to need to include a timestamp with it. The reason we do this is otherwise we don't really know at what point things are happening. Then finally, you'll want to start to make sure that you think about how you separate out the functions of the simulator from the chronotimer itself, because remember, we're trying to think of the chronotimer as running on its own, and that it doesn't know that the simulator is the one that's creating the events. So we're going to keep that separate. So the basic architecture of this should be that you have one large class that's going to represent the chronotimer, and of course it will have many component classes within it that help it do its work, and then the simulator is going to create the basic events that cause the system to respond. So in terms of your approach, and this is the spoiler alert if you've already got it going or you don't want to listen to this part and make it more of a challenge, you'll want to start to think about the chronotimer as having its top level features, and that it is delegating responsibilities for each of the different scenarios to different elements in the class. The other thing I encourage you to do is to create this domain model and start to think about how a race looks, how a racer itself looks, and how time looks, and how the race results are organized. And you'll probably want to go through several scenarios for this. Remember that the events that are coming in over a channel are simply events, and they are interpreted depending on the type of race that's being run. There's nothing significant or semantically important about channel 1, channel 2, channel 3, etc. It's how the events are interpreted from each of those, and that's one of the key learning objectives here, is that we're setting that kind of context. Now again, that's relatively complicated. So that's where we should be in this. Sprint 1 is basically getting us set up so that we can start up the chronotimer. that we can read in commands, just the ones that are needed for this sprint, and then and that includes power on, power off, starting a race of an individual, and then being able to detect a start and a finish and a did not finish. So it's fairly straightforward. You're basically starting a race, ending a race, recording the result, and also indicating what happens if somebody doesn't finish. And that's different than simply having a very long time. So that's what's kind of interesting about the way this works. And then that, of course, you'll want to use good coding practices, and then we'll do the sprint review in lab. Now the simulation lab this week will help you with a lot of this, because you'll get to do a lot of the same concepts of reading in from a file, executing a command, and moving on to the next one. And we call that an event loop. It's an event loop because what it does is it cycles through, and each time it's interpreting that command and dispatching the event to some part of the system and going back and getting a new one. So we call that an event loop, and that's a pattern that you're going to see many, many times in the design of complex systems. And so in many cases you'll be writing event-driven systems, and to a certain extent the chronotimer is in fact an event-driven system, meaning it's responding to events that are occurring outside of the system, and it is executing a command. Now you'll recall that when I talked about system use cases, we can start to think of them basically as the response to a command. And we're going to look at that as part of our use cases to services here.